Long-span bridge maintenance technology in Japan. The Honshu-Shikoku bridges, including the Akashi-Kaikyo Bridge, one of the longest suspension bridges in the world, were built by combing world-class technology to connect three routes between Honshu and Shikoku. This is where Japanese bridge construction and maintenance technology is fully applied. This section introduces those technologies that Japan is proud of, especially the technology of the maintenance phase. First, in the construction phase, the Seto Inland Sea where these bridges are built is deep, has a swift current, sea breeze and seawater cause salt damage, earthquakes and typhoons may occur, and there is frequent ship traffic. In addition, since it is designated as a national park, the beauty of the landscape also must be preserved. Due to these characteristics, the construction of the bridge was subject to various kinds of natural, social, and environmental constraints. This is why we developed new technology in a wide variety of fields, including investigative techniques for natural conditions, methods of design for substructures and superstructures, construction material, and construction methods. Some of the long-span bridges that were built overseas before the Honshu-Shikoku bridges experienced an exponential increase in maintenance costs as the years passed. In some cases, lack of funds has led to neglect of maintenance work, resulting in huge repair costs and traffic closures due to repair work and causing major economic losses to society as a whole. The following section introduces technologies for the maintenance phase in Japan, which have been developed based on lessons learned from these overseas cases. The Honshu-Shikoku bridges are an important asset of social infrastructure to enhance the daily lives of the population, and they cannot easily be replaced. Therefore, we have introduced the concept of preventive maintenance to control major deterioration before it progresses. Since the Honshu-Shikoku bridges are huge structures that are unparalleled, many problems arise when it comes to preventive maintenance. To implement preventive maintenance of high quality, we have introduced the concept of asset management, which is based on the accumulation and management of data and on the formulation and implementation of repair plans based on this data. Then, in the PDCA cycle of maintenance to enable effective management, the plan includes inspection, investigation, and diagnosis. Do includes the implementation of countermeasures, maintenance, and repairs. Check includes evaluation and confirmation, and lastly, action includes verification, improvement, and development of new technology. By repeating this cycle, we can continuously perform preventive maintenance. In the PDCA cycle of maintenance, the most fundamental aspects are inspection, investigation, and diagnosis. There are various types of inspections. Periodic inspections are divided into three types: patrol inspections conducted visually by inspectors on foot, basic up-close inspections conducted on bridge sections using work inspection vehicles, and precise inspections conducted once every 5 years to check bridge integrity. In addition, there are irregular inspections conducted when abnormalities occur. We conduct daily those types of inspections according to purpose. In addition to periodic inspections, it is necessary to investigate long-term monitoring and predict deterioration, in order to preserve the soundness of the bridge. Many of the foundations of the Honshu-Shikoku bridges are located in the sea, and some of the foundations are made of steel. To protect them from corrosion, electrodeposit and cathodic protection methods are applied, and the effectiveness of these methods is constantly monitored. Moreover, since the sediment of the seabed can be washed away by strong currents, a scouring prevention measure is installed around the foundation of the Akashi-Kaikyo Bridge, and the seabed around the foundation is monitored regularly. As for concrete structures, we regularly collect a specimen of the concrete through non-destructive methods, to understand the progress of the internal salt content and neutralization for deterioration prediction, in order to determine the timing and extent of repair works and to implement countermeasures. On the other hand, some places are difficult to reach on long-span bridges. To inspect these hard-to-reach areas effectively and reliably, advanced technology is used, including measures such as infrared cameras and inspection equipment. Also, we use newly developed inspection technology to inspect the corrosion and the breakage on the inner parts of the suspenders which can't be checked visually. We have developed a system that records the status of a bridge and the repair history, which is obtained through inspections, surveys, and diagnoses, as it accumulates data to evaluate the soundness of the bridge. Next, in the PDCA cycle of bridge maintenance, includes preventive measures such as monitoring and repairing. The Honshu-Shikoku bridges are long-spanning. Therefore, it is possible for the bridges to become greatly deformed or to behave unpredictably due to wind or earthquakes. To continuously monitor the movement of the girders and towers, we have installed a wide variety of monitoring devices. When the bridge was designed, the movement of long-span bridges had already been studied in detail. However, by observing and analyzing the bridge's actual movement, the validity of the design is confirmed and the results are utilized to plan long-term maintenance. Many long-span bridges are made of steel and corrosion is a serious threat in terms of their maintenance. Therefore, corrosion protection is very important. A wide variety of methods are used to prevent corrosion in the different areas of the bridge. The entire bridge is coated with paint, the concrete areas are coated with a particular coating material, and electrodeposit and cathodic protection methods are used on the steel caisson that surround the foundation of the bridge. In addition, a dry air injection system is installed in the main cables of suspension bridges, and a dipping coating and an anti-corrosive material injection are applied to the suspender ropes, which connect the main cable with the girder. Nearly half of the repair costs for the Honshu-Shikoku bridges come from the cost of repainting the bridges. To extend the repainting cycle of the Honshu-Shikoku bridges, we have developed a durable, multi-layered coating system used since the construction period. As preventive maintenance, we repaint the intermediate and top coats before the undercoat is exposed. In this way, we can reduce life cycle costs by preserving the function of the coating film that protects the steel from corrosion, while making repairs as cost-effective as possible. Next, we will introduce a dry air injection system for suspension bridges, that is a unique corrosion protection technology. This system means that the air supply equipment for managing the temperature and humidity of the air is installed in the maintenance pathways. The dry air is sent to the main cable through the air duct, which is installed along the main tower and main cable. The system is constantly being monitored and, if there is an abnormality, an alert message is sent, and the malfunction is immediately reported. The monitored data are stored, analyzed, and utilized for the continuous improvement of the system. Next, we will introduce steel caisson corrosion protection, a corrosion protection technology for foundation structures. The foundations of the Honshu-Shikoku bridges are built using the laying down caisson method, in which a steel caisson is submerged and filled with concrete. Caisson were originally designed as temporary concrete molds, and were not considered important. However, the steel caisson of the Honshu-Shikoku bridges protect the bridge foundations made of concrete for a long period, so corrosion protection measures are applied to the caisson. As part of the major corrosion protection methods for steel caisson, the first is called the electrodeposit method, which generates an electric current from an anode installed in the sea. Inorganic materials such as calcium carbonate and magnesium hydroxide, which have positive ions, are deposited on the surface of the caisson on the cathode. The inorganic materials are deposited uniformly on the surface of the caisson, where they form a protective coating that protects the steel caisson from corrosion. This inorganic material exists in nature in forms, such as shells and dead coral, so this corrosion protection method is environmentally friendly. Another method is called cathodic protection. On the surface of the caisson, a sacrificial metal is attached and wired to the surface of the caisson. The sacrificial metal corrodes easier than the protected metal and, in this case, the steel caisson. This is how the steel caisson becomes protected from corrosion. Finally, we will talk about concrete coating. One of the patterns found in the deterioration of concrete is the corrosion of internal reinforcing steel, which allows deterioration to progress. The reinforcing steel expands by rusting, causing cracks in the surrounding concrete. In a worst-case scenario, the concrete peels off, creating danger to a third party. To avoid that situation, the surfaces of the concrete structures of the Honshu-Shikoku bridges are covered by a coating, to protect them from salt and moisture which cause deterioration. In addition, check in the PDCA cycle includes verification and monitoring of repair effects, and action includes a review of technical standards and deterioration prediction. This is how we conduct the whole PDCA cycle in maintenance. In this way, we will achieve a higher level of maintenance technology and efficient management. Furthermore, by more efficiently repeating the PDCA cycle based on the idea of preventive maintenance, we will strive to avoid large-scale rehabilitation and thus reduce life cycle costs. Today, we introduce some of the technologies for the construction and maintenance of long-span bridges in Japan. Japanese engineers are overcoming various natural environmental constraints to support the smooth movement of people and goods. We would be very happy if we could make a small contribution to the construction and maintenance of bridges around the world through the construction and maintenance technologies that Japan has fostered over the years.